Hey YouTube! So today I'm going to talk about what was involved in finishing this polished vertical slice for the puzzle section of my game, and bringing the characters to life with some animations and some sound. So let's get started. So in the last video I had established the theme of my game, which is that you'd be running a restaurant and customers would come in and you'd feed them and fatten them up, and then they'd leave and you'd get new customers. So for this to work, I needed to have a way to render a lot of different kinds of customers. I didn't want it to just be the same 2 or 3 guys, and I needed a way to make them get fatter and fatter as you fed them. So to get the variable customer appearances I was going for, I figured I could get away with like a Mr. Potato Head approach where maybe there's a different set of eyes and a different set of mouths, and you can sort of mix and match those randomly and switch the color palettes as well. I drew a lot of different variations, and then I just picked my favorite 2 or 3 for now. I figure I can add all the variations I want later, but for now I just needed the proof of concept. So for some of my simpler animations in my other games, I just drawn them in Paint Tool SAI, but for this one I decided I should bite the bullet and learn Clip Studio Paint, which has a more robust animation suite. It lets you do things like thumb through animation frames one at a time, turn on onion skinning to see the previous and next frame. This is stuff you can do without it, but it just means you have to have all of your frames laid out in folders and turn them on and off. Clip Studio Paint saves me a lot of hassle at the cost of having to learn a new tool. So after I drew and imported all these textures and animations into my game, everything worked all right, except I noticed the game became a lot slower to start up. Instead of starting up in a second or two, it was now taking like 40 or 50 seconds, and I traced this down to the overhead involved in importing all these large sprite sheets. So the solution I came up with involved writing a custom piece of code in the customer object, where rather than setting his textures when his appearance changes, which would cause a stutter, or loading his textures on startup, which would cause the game to take a while to start up, instead he loads them in a separate thread. So he calls this customer loader object, and that customer loader kicks off a thread to load all the textures in the background. This works all right in the game because thematically, people are coming to your restaurant, so if they disappear and then they come back, it makes sense. The customer left, and then a new customer came back. It would actually be more jarring if they changed their appearance instantaneously. So as far as how I got the creature growing in size as he eats more food, that was with this animation player called a fat player, and it has a 10-second long animation, but that's not really 10 seconds. That's really just 10 units because I play this animation as fast as it needs to be played to get them to their appropriate size. So as this gets further in the animation, though, the body's fatness attribute increases, as well as these other positions. So the fatness attribute affects how big the stomach object is drawn. And then the arm and leg positions make sure that the arms and legs move out from the body so they don't just look weird and clipped. As far as how that body's drawn, that was a custom job because Godot does not actually have out of the box any real way of drawing like a path sprite or anything like that. So there's a little custom script here which stores a list of curve definitions as points, and then does a little bit of custom linear interpretation down here between the nearest 2 points. So scrolling up again, for example, we define what the creature's stomach looks like at size 3 fatness versus 5 fatness versus 10 fatness. And those corresponds to the different timestamps in this animation. So then later, when set fatness is called with like 6.6 or whatever, we'll do a linear interpolation between the curve of the 5 fatness creature and the curve of the 10 fatness creature. So it results in that smooth look where it can adopt any fatness from 1 to 10 and it looks smooth. So as far as sound effects, someone on the game dev subreddit pointed me to Sonus.com, which was a website which lists professional sound effects libraries, which you can use for indie games. The price usually ranges from about $20 to $100, which is not beyond my budget. So I bought one pack which was intended for cooking games, which seemed like a good fit, as well as a pack which provided cute monster voices, which I thought would match the voices of my chef and maybe the customers, and then a third library which provided just general use sound effects for things like explosions or thumps or bells. So I'm using all 3 of those in my game now. I tweaked some of the sound effects in Reaper where it was necessary, but a lot of them just went into my game as is. The last detail I wanted to nail with regards to gameplay was the concept of piece kicks. Piece kicks, if you're unfamiliar with them in Tetris, are basically when a piece can't rotate because a wall or another object is in the way, what happens? Usually it'll move somewhere else where it can rotate, but the question of where it moves to is a hard question. So piece kicks are typically implemented with these big intimidating tables of coordinates, which say if a piece can't rotate clockwise, it'll try to move left and rotate. and then it'll try to move down and right, and then it'll try to move left and down and so on. But how do you know if these are right? You don't really. It's more of a trial and error thing. But I thought this is something that could easily break in the future if someone tries to change these tables, so it would be a good time to unit test. So there's a great unit testing library for Godot called Gut, which lets you unit test your game code. I wouldn't do this for all my code, but for stuff like these piece kicks, it makes sense because you really don't want these to break or to regress in the future if someone changes them. So I created a suite of unit tests against the pentomino piece kicks, which show how each of them should rotate when they're blocked. For example, this test here, test P pump kick 0, shows if a P block is oriented here on its side, and then you try to rotate it counterclockwise, but there's some stuff in the way, it should still rotate counterclockwise, it should just go into that little nub. Or if it's vertical, and you try to rotate it clockwise, it should slide down into that nub. And this isn't just ASCII art for the sake of ASCII art, and it's not pseudocode. This is actually the test code which executes. This assert kick method is a method in the test base which dissects those diagrams and figures out, okay, well, you have a colon there, so that's where the wall should be. I thought this was a lot more maintainable than just arbitrarily saying, well, P piece at coordinate 2, 3 with orientation 0 and blocks at 1, 2, and 1, 6 should rotate this way. That's not going to be maintainable. But this to me is just like a little picture a human being can look at and judge for themselves, well, no, that kick doesn't make sense. My kick makes more sense. And so this is more maintainable for the future. But overall, the benefits of these unit tests are that they act as documentation for these piece kicks, because nobody could look at this and figure out what the intent was behind each of these weird coordinates, why this is a 0, -1 and not like a 0, -3, who knows. But these unit tests describe, well, that should be 0, -1 because if it's in this case and they rotate clockwise, it needs to move down by 1. So they can understand this picture. They can't understand these kicks. So these unit tests are our way of documenting what the kicks are supposed to do. So that's where the game is as far as April. You can see we got customers, and they eat food as you clear lines and stuff. They get fatter and fatter, and then when you break a combo, a new customer comes in. And all the customers have different colors and appearances. And then you can also hear, every time a customer leaves, there's a little jingle of like the door, and sometimes they say hello or goodbye when they leave or show up. There is still more polish I'd like to get on this part of the game as far as having the frosting. Maybe it would be cool if the frosting like splooshed in from the top and there were particle effects. And I definitely want a chef over there making the food and serving it so it doesn't just randomly teleport in. But before I do that stuff, I really want to get started on the second half of the game. And the second half is going to be this whole overworld where you're walking around and talking to people, and then those people come to your restaurant. So I want to make sure that half of the game also works. So the next piece I want to get is a vertical slice of the overworld half of the game. So that's what I'm going to hopefully cover in my next video. See you guys in a month.